Morning, everyone. I'm Wen Jing, a student working with Professor Jing Kong. I'm here to present our team from MIT and Master Institute. We aim to develop an integrated technology to treat wastewater using electromembrane biochemical reactor and nanowires. UAE is one of the driest countries in the world. It has the largest water consumption, but very limited natural water resources. It is heavily reliant on recycling wastewater and desalination of seawaters. However, only 57% of the wastewater has been reused. The rest, 43% of the wastewater was dumped in the sea. The city of Abu Dhabi aims to recycle 100% wastewater reuse by 2018. They want to use those dumped wastewater for other domestic or industrial purposes. There are two main challenges for 100% wastewater reuse. First, there is lack of adequate infrastructure to collect all the wastewater, transfer them into a centralized wastewater treatment plant. After treatment, they have to redistribute them. Second, we have to find better applications for improving water qualities. Here we propose an all-in-one standalone wastewater treatment technology. The picture on the left shows a traditional wastewater treatment plant. You can see they have different segments. Different segment was designated for treating specific types of pollutant. Each segment, as shown here, the huge water tank occupies huge land and requires high maintenance cost. In contrast, our technology is much smaller. You can install it in communities or shopping malls that can help recycle water on site. Here is the process of the wastewater treatment. So on the left, the wastewater was enter the EMBR system directly for partial removal of particles, organics, and inorganics. This is the first step. After the first step, the effluent will enter the nanowires for further removal of heavy metals and organics. After these two steps, we expect the water can reach the irrigation standard. A third step of titanium oxide nanowire will be applied to meet drinking level standard. This is because under the UV light, the titanium oxide has the photo-induced catalytic effect to decompose all the organics and kill bacteria. Here are the corresponding pictures for each stage. So the first one shows the starting wastewater collected from the sewage in city Abu Dhabi. The second shows their system, but that was taken from last year. With the support from the Dish Pump Center, we upgrade the systems that can recycle wastewater in continuous mode 24/7. The third is a picture of our nanowires. It has a diameter of around 100 nanometer. It has extremely high surface areas, can absorb or remove all those pollutants. And the last one is the treated wastewater, and it's much clearer compared to the original one. Before we jump into all the numbers, I want to give a brief introduction. So there are two types of wastewater. One is municipal wastewater, and the other is still industrial wastewater. Different types of wastewater will have different content of different pollutant. For example, the municipal water will have more organics, while the still industrial water has more iron content. We will study the removal capability of 6 different combinations. There are a lot of parameters for evaluating the quality of the water, and we divide it into 4 categories: organics, heavy metals, inorganics, and bacterial content. And for the treated wastewater, it will have different applications. We can use it for irrigation, industrial cooling, or drinking. Our final goal is that we can match up the solution once we're given the types of wastewater, and we know what we want to use it for, and we pick the right technique. So this is the results of our treated municipal wastewater. I highlighted the important information here. So after the treatment, it meets irrigation standard, and most of the parameter has met the drinking water standard, but we're still working on it. And we found similar results for industrial wastewater, even though it has different pollutant content. This slide shows a preliminary microbial analysis using the BCE and magnesium oxide nanowires. You can see the bacteria count has been greatly reduced. But here, this year we used the improved EMBR system, and hopefully with the help from titanium oxide, we can completely remove all those bacterial content and meet the drinking water standard. We have also studied the current technology has been used to treat wastewaters. So those data are all collected by one of the consulting companies. The 4 listed technologies are very effective at removing specific types of pollutant, but our technology aims to remove all in one system. Finally, our EMBR and the nanowire system show that it can treat water to meet the irrigation standard in city Abu Dhabi. We have to work on some of the bacteria account parameters to meet the drinking level standard. We hope to contribute to the Abu Dhabi's goal to reach 100% wastewater reuse. And we will also explore more different designs to meet the standard. Here, we would like to thank our catalyst, Maria and Earl, and Dishbon Center. Thank you very much. If you have more questions, please come to our poster.